To manage our vCenter inventory effectively, there are a few different tools we have in our tool belt. The first tool being the vSphere objects that help with organization, specifically the different organizational and hierarchical objects that are available to you as an administrator in the vSphere inventory, starting with clusters. When you create a cluster, that cluster of, let's say, 3 physical hosts might be used to run a specific application. So you would run and perhaps even store, if you're using, for example, VMware vSAN, all of the virtual machines related to a specific application that run on that cluster in order to not only execute those workloads, but also to really help with the organization. Those virtual machines run on that cluster with those hosts. Another organizational resource is folders. You can create folders at most organizational levels and place virtual machines inside. You can also create resource pools, and you don't always have to strictly assign specific resources or limit resources on a resource pool. You can simply place virtual machines inside and then use it as a point of organization and perhaps resource monitoring. Another organizational unit is the vApp construct. We've talked about vApps. If you have a multi-tiered application, for example, 3 web front-end servers, 2 analytics servers, and 2 backend database servers, all of these servers or virtual machines, in the case of vSphere, could run in a single vApp, and then you could use that point of administration for assigning permissions, role-based access, resource monitoring, performance control, and even cloning and templating of the entire multi-tier application as a single unit. Here in vSphere, for example, the different organizational units we talked about, the first one being the cluster concept. Here we have 2 different clusters. Each has its own physical hosts and associated virtual machines, as well as other types of organizational resources, such as here is the vApp that we created. You can also have resource pools. For example, here is a resource pool that contains 3 different virtual machines. And I can also right-click on a host, and while I cannot add a folder at this level in the vSphere inventory, I can actually go over into, for example, virtual machines and templates, and it's here that I can create a new folder. For example, a new virtual machine and template folder, a new storage folder, new network folder, new hosts and clusters folder, and use this as a point of organization. I'll just call that test. And then I can easily drag and drop virtual machines into this point of organization that we just called test. Let's go ahead and put that back how it was and remove the test folder that we just created. So those are some of the different types of vSphere objects to help you organize your vCenter inventory more efficiently. Now let's talk about another tool, and that is to use a naming convention. My friend Elias Knaser, who is a fellow Pluralsight author of numerous Citrix, cloud, and virtualization training courses, wrote an article many, many years ago on this specific topic. And during my research for this lesson, I discovered his article. And I thought it was still very timely today because the idea of creating naming conventions is simply evergreen content. It's not something that's going to change very often. And what he recommended was that your naming convention should always be used to identify a location and a purpose of the virtual machine or the object that you're naming. It should be simple but meaningful. It should always be consistent. You should only use alphanumeric characters and only use numbers at the end of the naming convention. And then finally, avoid product or vendor names with some exceptions. For example, things like web for web server, SQL for SQL Server, maybe even Oracle for Oracle Database Server. He also recommended that your naming convention should be formatted with header-variable, where the header is represented by GGLT and the variables are represented by AAA, BBB, followed by 2 or 3 numerical digits. You might be wondering what those letters stand for. Well, it breaks down into G is for geography. For example, HH might be for Hilton Head, or NY might be for New York, or LA might be for Los Angeles. L is for the location, which could be data center, T for test lab, C for colo, or any other unique letter you want to use for identification of the location. T being for the type of server, for example, V for virtual, P for physical, C for cluster, followed by the variables, which are AAA, which represents the purpose, and that could be ORA for Oracle, EXC for Exchange, CTX for Citrix, ESX for VMware ESXi host, and BBB for the application that runs on that host. For example, POS for point of sale, or EPC for Epic, followed by a number, and that number represents just the incremental number of these same types of objects in the inventory. And you should note that this naming convention doesn't just have to be for the virtual infrastructure. It could and should be across the entire network to include perhaps even desktops, laptops, printers, and other sorts of network devices. Some examples could be HH for Hilton Head, D for data center, V for virtual, and then SQL point of sale number 22. That would be the Hilton Head data center virtual machine running SQL for the point of sale system, the 22nd instance of that virtual machine. Another example could be NYTP-FS LIN 19, which would stand for New York Testing Physical Host File Server Running Linux number 19. You can see how these naming conventions could get very complex, but by creating that standardization, any administrator could simply look at the name of the virtual machine or the host on the network and immediately know the location, the type of data center, the application, the operating system perhaps, and whether or not the device was a physical host or a virtual machine. Again, kudos to Elias Knaser for his excellent post on this topic, but this isn't the only way to do it. I want to stress, this is just a suggestion. You should do whatever works for you and what works for your company. Now, over at the Wired Brain Coffee Company, we have implemented some form of naming convention, but honestly, we have a ways to improve this. We have been using a 3-character sequence at the start of the name to identify the purpose, for example, log or SQL or web, followed by a dash, and then the operating system, in this case, it's Windows, followed by a dash and a number. However, as you can see, we have some opportunities for improvement. For example, we have here log web 1. This should really be, if we're going to follow the naming convention, we can right click on this, rename it, and it really should be log win 1. And it's the same thing for this SQL server right here. To follow the naming convention where the operating system is the second set of characters, it would be SQL win 1. And then up here on the ESXi host, we really don't have a good naming convention going. We just have node 1, 2, 3, and 4. And then not all of our virtual machines are following the same naming convention. So you as a consultant really need to help out the Wired Brain Coffee Company here. I encourage you to do it in your own environment. See what you can do to come up with your own naming convention and do your best to make the management of the vCenter inventory as efficient as possible. As a vSphere administrator, you should know that virtual machines can have multiple power states. It's a lot more than just power on or power off. Here in the vSphere client, if we look at a specific virtual machine, you can tell simply by the icon with the play button shaped like a triangle that this virtual machine is already powered on. You can also see that right here underneath power status where it says that the virtual machine is indeed powered on. If we were to right click on the virtual machine, we could go up to power and you can see that power on is grayed out. So we can't power it on because, well, it's already powered on. You can also see that there are a number of other power states available. They are power off, which would be just like pulling the plug on a physical host. It immediately disconnects the power to the virtual machine with no graceful shutdown of the applications or the operating system. So you have the potential there for some data loss. You also have the option to suspend a virtual machine. You can think of suspending as pausing a virtual machine, or if you've ever had a laptop that you put into sleep state where the memory is saved to the hard drive, you shut it down, and no power is consumed until you go to power that laptop back on, at which point the contents of the memory are read from the hard drive and brought back into memory, and all running applications and data are immediately back as they were in a running state. That's what suspend does to a virtual machine. It doesn't power it off, it just puts it to sleep, and the status of the memory and the contents of the memory are preserved. And then you have reset, which is kind of like the old physical PCs. If you remember that, they always had a reset button on the front. You push the reset button, and it's like a momentary blip in the power where the machine is powered off and then immediately back on. It's really the same thing as powering off and then powering on. And then we have two other options below, which are only here because we have the VMware tools installed. I can tell you if the VMware tools were not installed, these two options would not be available. So because VMware tools is inside the operating system and vCenter can communicate with VMware tools, you can initiate a shutdown of the guest operating system just as if you went into Start and chose to shut down Windows. In this case, because this is the Windows operating system, a shutdown of Windows would be initiated, and maybe 45 seconds later, 30 seconds, whatever it is, the operating system would power down, and then the virtual machine would power off. You can also initiate a restart of a guest virtual machine by using the Restart Guest OS option. Of course, all these power options are also available here in the Actions tab, and two of them are even available across the top here. We have Shutdown Guest OS, and if the guest OS was shut down, for example, right here, let's go ahead and do that. You can see the guest OS is shutting down. Let's give this a few seconds. And there we go. That was a clean shutdown of the Windows operating system. And now if we push refresh, we have a power on for this virtual machine available as an icon. We'll go ahead and power that on. We get a message, of course, because this is part of a vApp, but that's okay. And in just a moment here, this Windows virtual machine will be powered back on. And there we go. Now you can also go in and edit the settings of a virtual machine. If you go into the virtual machine options inside VMware tools, it's here that you can see the power operations that will be available for this virtual machine. And you can actually change those, but the virtual machine has to be powered off before you make that change. So that's how you differentiate the different power states of a virtual machine. So like I said, there's a lot more to virtual machine power states than just powering it off and powering it on. But now you know how to differentiate the various power states available to you as a vSphere administrator. There's a lot that you can do when it comes to configuring virtual machine options, power options, and boot settings. If we go into the vSphere web client, it's best to power off or shut down a virtual machine before you start to configure some of these options. With a clean shutdown of the guest OS, let's go into the virtual machine settings and then into the VM options tab. And first we'll talk about power options underneath VMware tools. It's here that you can configure what these different buttons will do. For example, the power off button could either power off the virtual machine or it could shut down the guest operating system, whatever you prefer. The pause button could either suspend the virtual machine or suspend inside the guest operating system if your guest supports that. The restart button could either restart the guest inside the guest OS or perform a power reset on the virtual machine completely. The difference being, if you restart the guest, you're going to have a clean shutdown and a clean boot up. So those are your different power configurations. There are also power management settings where you can choose what will happen when the virtual machine is put in a standby state. Will it put the guest OS into a standby or sleep state, or will it suspend the virtual machine? Looking at some other options available to us in the VMware Options tab, if we scroll on down, let's look at boot options. Here underneath boot options, you can choose which type of firmware you want your virtual machine to have. It could be BIOS or it could be EFI. EFI is newer and recommended. If you remember the old physical hosts, they would have BIOS EPROMs that you could pull in and out and replace and upgrade. No more. Everything is virtual. So here we have virtual BIOS that we configure some settings on so that when this virtual machine is powered on, the BIOS is the very first thing that's executed. And then from the BIOS, hopefully the virtual machine will be booting up. Now, it is possible here to force the virtual machine to boot in the BIOS. If you aren't quick enough to push the button to go into the BIOS, sometimes using this option is very helpful. Let's go ahead and use that. We'll launch the remote console, power on the virtual machine. And then as you can see, we were immediately booted into the BIOS without ever having to push any sort of hotkey or button to boot into the BIOS. This way we can immediately access the BIOS. Sometimes it's hard to catch the button that you need to push to go into the BIOS. But by using this option, we are immediately booted into the BIOS if we want to make some sort of configuration changes. So you should know that a virtual machine really works just like a physical host. You've got BIOS boot order in here. You can boot from hard drive, CD drive, network boot, removable devices. Keep in mind that these are all physical devices. You can also go into advanced settings and more. Let's go ahead and exit without saving. And our virtual machine boots up again, but this time it doesn't go immediately into the BIOS. That's because the option to force the VM to go into the BIOS only works one time. We'll push Control Command to exit this virtual machine console. Otherwise, our mouse was locked inside. And then we'll go ahead and tell this virtual machine to suspend. So when we click suspend, what exactly is happening to this virtual machine? Well, as we talked about, these virtual machines can go into a sort of sleep state if we choose to do that, where the contents of the virtual machine's memory is preserved. And that's what this virtual machine has done. We are in a suspended or sleep state. To get out of this, we'll click power on. The virtual machine will recover from its sleep state and it's back up and running immediately where it was before. If we go back in to edit the settings of this virtual machine, we looked at power options and power management. We looked at boot options. Notice to change the boot options, the virtual machine has to be powered off. Let's go ahead and go into actions. And since we don't have VMware tools installed, because this virtual machine is actually not even booted up, so the virtual machine tools can't be accessed, we'll go ahead and just physically power off this selected virtual machine. And then at that point, we can go back into edit the settings, go to the virtual machine options, and into boot options, change our BIOS back to EFI. And before we do, let's check out the advanced virtual machine options. This is where you can configure things such as logging, debugging and statistics, swap file location, and custom configuration parameters. I'll click OK. And then let's power this virtual machine back on one more time. We'll go to the VMRC, and here we can see that the virtual machine has indeed booted up successfully. One of the most powerful features of VMware vSphere is the ability to take a snapshot of a virtual machine, which is really a picture in time of that VM. It may or may not include the virtual machine's memory to preserve running applications and data, but it gives you the ability to preserve the state of that virtual machine, make changes, and then revert back to the previous state if you need to. Don't consider it a backup because it's not truly a backup, but it is a way to protect yourself if configuration changes or software updates go wrong. You can easily revert back to the snapshotted virtual machine state and get the virtual machine back up and running. To take a snapshot of a virtual machine, you can go to that VM, and right here on the top, you'll see an icon that says take a snapshot. By default, the snapshot will have a name with VM snapshot, the date, and the time, but it's recommended to create some other name or at least a description. For example, before Windows Update. You can choose to snapshot the virtual machine's memory if you'd like. Of course, that would preserve running applications and data, and click OK. We can check the status of the snapshot. It'll take just a moment to create the snapshot. And once created, we could go into the virtual machine. And then from here, perhaps we perform an upgrade or we make some configuration changes. And then let's say that there's a problem and we need this virtual machine to go back to the state that it was at before. Thankfully, since we performed our snapshot, we'll go up here to Actions and down to Snapshots. And then we could, in one click here, revert to the latest snapshot. I'll say yes. And in just a moment, we are back to the point that we were at before. And in just a moment, we're back to the point that we were at before when we took the snapshot. Now, you can also go into Actions and then into Snapshots and manage your snapshots. And it's here that over time, as you take more snapshots, you can essentially form a snapshot tree where you can revert and then you can take a snapshot from there and you can take another snapshot and another snapshot. And then you can revert back to 3 snapshots back and then take another snapshot. So you have a lot of flexibility here. And like I said, this is so powerful for anyone who's doing testing or development, and especially for administrators who are making configuration changes and updates. So that's how easy it is to administer virtual machine snapshots in VMware vSphere 7. And one last thing, you can even go up and click on Snapshots, and it's here that you'll receive the same snapshot management view that you would receive if you went into Snapshots from the Actions menu. So that's how easy it is to administer snapshots in vSphere 7. In my vSphere 7 storage course, we covered in greater detail exactly what storage policy-based management is, known as SPBM. It's a really cool feature of VMware vSphere that allows you to create software-based storage policies as a single control plane across all different types of storage devices. It is in itself an abstraction layer for managing different types of storage. For more detail, I encourage you to check out my vSphere 7 storage course if you haven't already. In this lesson, I'm just going to remind you exactly how you go about assigning a storage policy to a virtual machine, and then in the next lesson, we'll check to see if that virtual machine is in compliance. To assign a storage policy in vSphere, you go to the virtual machine, simply right-click, and go to VM Policies. It's here that you can edit the VM storage policies, and they are assigned per disk as well as for the virtual machine home directory. Typically, they'll be assigned the default storage policy for the array or storage device that these storage objects are being stored on. For example, both of these objects were stored on VMware vSAN, so they receive the vSAN default storage policy. Whereas this hard disk was stored on the iSCSI SAN, so it received the data store default storage policy for the iSCSI SAN. Now, to change storage policies, you simply click the drop down here and then select the storage policy that applies to you. The cool thing here is that the storage configuration and profile can be seemingly changed dynamically. For example, if you need higher availability, greater resiliency, greater performance, maybe you want this virtual machine disk striped across 10 disks, and you create a storage tier based on that, you could create an associated storage policy. And then if I want this virtual machine disk file to have that higher storage performance, I can simply select the gold tier storage that might give me that storage performance, and then the underlying data will be automatically distributed with no downtime for the virtual machine's applications or end users. Of course, if you go in and edit the settings for a virtual machine, you'll find the storage policies are also configurable on a per virtual disk basis here in the settings as well. Now, just because a virtual machine has a storage policy assigned to it doesn't mean that it meets that storage policy. You need to periodically check to see if your storage policies are in compliance. Thankfully, that's easy to do. In fact, if we scroll down right here on the storage policies widget, you can see if this virtual machine is in compliance with the storage policy that's assigned. You can see the last date that it was checked, and you can simply click here to check compliance. So for example, if I right click on this virtual machine and I change the virtual machine storage policy for hard disk 2 to the vSAN default storage policy and click OK, you can see our storage policy compliance has changed to a question mark and it says that it's unknown. I'll click check compliance, and if we check the status of the task, you can see that it did complete, but our storage policy compliance is still unknown. The reason for that, to be clear, is if we go back into the virtual machine policies, I can tell you here that the data store does not match the current VM policy. And because of that, the storage policy hasn't changed. That's because this virtual machine disk file is on an iSCSI SAN when we configured the vSAN storage policy to be applied to this iSCSI SAN, and simply it's not going to work. Now we could change this, for example, to the bronze tier storage policy, but it tells us that this data store does not satisfy compatibility. We could also specify, for example, high availability, but again, this data store does not have that functionality. So in that case, let's just go back to the data store default. We'll say OK. We'll check our compliance, and you can see the virtual machine is now compliant. So that's how to check the status of your storage policy compliance and ensure that your virtual machine disk files are aligned with the requirements of your storage policies. Whenever you're administering virtual machines, periodically the resources just aren't going to be enough. Or on the other hand, they could be too much and you could be wasting resources. But more often than not, you'll be running low on resources. So how do you tweak the virtual machine resources that are assigned, specifically CPU and memory? We'll be talking more about expanding virtual disks in our next lesson. But for now, let's hone in here on CPU and memory, because outside of virtual disks, those are the top two most frequently changed resources. And I should point out that we will have an entire course in this vSphere 7 learning path covering resource management. So don't think that what you're going to learn in this lesson is all that we plan on providing you. We'll have a lot more on this topic. But for now, it's important to know how to perform simple CPU and memory resource changes on a virtual machine. For example, I've got a virtual machine here, and let's say that it's running out of CPU and memory. We'd like to add additional CPU. We have 2 CPUs, or really 2 cores in one virtual socket assigned to this virtual machine. We also have 4 gigabytes of memory. And you'll notice that both of these settings are grayed out. That's because this virtual machine is currently powered on. If we were to power off the virtual machine, actually shut down the guest operating system, let's give this just a moment. And with the virtual machine powered off, if I go back in to edit the settings, you can see here that I can easily increase the number of CPUs all the way up to 12. In our case, we'll just consume 4. And then with memory, again, I can increase this all the way up to very large numbers, even set this in an increment of a terabyte. In this case, 4 terabytes. But we really don't need that much memory. Let's go back to gigabytes and let's just change this to 6 gigabytes. I'll click OK. The virtual machine's configuration was changed, and I'll click power on. With the virtual machine powered on, you can scroll down and see the virtual machine hardware. We now have 4 vCPUs assigned and 6 gigabytes of memory. When it comes to consumption, you can see here that 0 hertz are being used from the 4 CPUs allocated, and 0 bytes are being used from the 6 gigabytes that we allocated. Now, in some cases, CPU and memory can be added with the virtual machine powered on. This is called hot add and hot plug, but that's not something we're going to go into at this point. For now, you should feel good that you can easily tweak the CPU and memory resources of a virtual machine anytime you need to because it's quick and easy to do. When it comes to extending the disk capacity of a virtual machine's virtual disk, this is something that you can do with the virtual machine powered on. This is called hot extend, meaning the virtual machine is hot or powered on, and you're able to extend the virtual disk. It's important to know how to do this in the event that an important virtual machine is running out of disk space and you need to extend the existing disk space fast. Take, for example, this Windows 2019 virtual machine. If we go into the configuration or settings for this virtual machine, you'll see here that we have one hard disk that we started off with. It's 110 gigabytes. And then for the purposes of this lesson, I've added a second hard disk, which is just 1 gigabyte. Now, what's important to know here is that if you look at these two hard disk number 1 is connected to virtual device node NVMe controller 0. So this is a virtual NVMe hard disk. However, if we go up to the 1 gigabyte hard disk that I've added for the purposes of this lesson, you can see that this is a SCSI hard disk connected to a virtual SCSI disk controller that I also added for this demonstration. So the reason for this is if we go into the virtual machine and then go into disk management, you can see drive letter C, which is the 110 gigabyte virtual disk. However, it appears only as 90 gigabytes. That's because when I tested this, what I found is as I increase the size of the virtual disk on the virtual machine, the Windows operating system would not recognize it. And I found that that was because it was an NVMe type device. However, when I added and even increased the size of the SCSI device, which is down here, disk 1, I found that the Windows operating system immediately saw those changes. So when we talk about hot extending, we're talking about extending the size of a virtual disk without having to shut down the operating system. But keep in mind that this is a two-part process. Yes, you can extend the virtual disk size anytime you would like in VMware vSphere. However, the operating system, no matter what it is inside, be it Linux, Windows, or some other operating system, has to also recognize that change and allow you to dynamically increase the size of the virtual disk inside the operating system. So for this demonstration, if we go back to this virtual machine, we go into settings, and let's say that this virtual machine's hard disks are running out of space. And indeed, if you look at drive E here, you can see that it does only have 4% free. So it really is running out of space on drive E. However, we still have plenty of space on drive C. But let's just pretend for the purposes of demonstration that we are running out of space on both of these. So if we were to increase the size of hard disk 1 to 200 gigabytes and increase the size of hard disk 2 to 100 gigabytes and click OK, you can see that dynamically the virtual machine is reconfigured. Those virtual devices are reconfigured. And if we scroll down, there's hard disk number 1. It's now 200 gigabytes. If we go into the settings, hard disk 2 is now 100 gigabytes. However, if we go back to the virtual machine, what you'll see here is that immediately there are no changes. Drive C is still 89 gigabytes, and drive E is still just 1,000 megabytes or 1 gigabyte. But if we push refresh, there's the change to drive E. That's the second virtual disk. There is now another 99 gigabytes that is unallocated for a total of 100 gigabytes. However, drive C, the NVMe virtual disk type, doesn't seem to immediately recognize this change, even when I refresh and repoll the disk status. So this is something we'll have to look into more. The NVMe disk type is very new. Traditionally, when I did this in previous courses and demonstrated it, it was always with the SCSI disk type, which is why I was initially thrown off by the fact that drive C didn't seem to ever recognize the increased disk capacity without a reboot. So I'll tell you, if I do reboot this virtual machine and come back in, drive C will immediately have the unallocated space. In fact, let's test that. So I'll click here to shut down the guest operating system. Let's test that. So if I go into Actions, Power, and restart guest operating system, I'll say yes. Let's give this just a moment to complete. And with the virtual machine restarted, we'll go back in to disk management and take a look at that. Disk C now has 110 gigabytes of unallocated space, but that only showed up after we restarted the guest operating system, whereas the new space for the SCSI virtual disk immediately showed up. And so let's assume that we never restarted this virtual machine to dynamically allocate the new disk space to disk 0, which is online, healthy, and only has 4% disk space free. So if I go to drive E and click on extend volume right here, that's what I was always looking for on drive C, and it was grayed out. So we'll click to extend the volume, click next, next, and finish. And look at that. We just extended our volume to 100 gigabytes. That's drive E. It only had 4% disk space free. Now it has 99% disk space and 99 gigabytes free specifically. We can also, of course, now extend drive C, extending this by another 110 gigabytes. But again, that disk space was only free once we restarted the virtual machine. So technically, it wasn't a hot extension of the virtual disk space, but you did learn how to dynamically extend your disk space. And it's important to know that whether or not you can hot extend your disk space without shutting down your guest operating system is really based on the type of virtual disk controller and the type of virtual hard disk that you're using on your virtual machine. And of course, whether or not you can hot extend your virtual machine storage is going to depend also on your guest operating system. Again, this is a two-part process: extend it in vSphere in the virtual machine settings, and then go in and extend it inside your guest operating system.